Now it's time to learn LL1 parsing. Now before we understand LL1 parsing, how do we do it? Let us check out all the questions that are asked. So these are the questions that are asked. Check whether the following grammar is LL1 or not. And this is a grammar. Check whether the given grammar is LL1 or not. And they give us a grammar like this. Check whether the given grammar is LL1 or not. So all of these are same kind of questions. We have to check whether the given grammar is LL1 or not. So how do we check it? Before we understand that, let us understand what's the meaning of LL1. So there are different kinds of parser. We have top-down parser that start from the top, and we have bottom-up parser that start from the bottom and then they go up. Now in top-down parser, we have RDP and we have LL parser. In bottom-up parser, we have parsers like LR parser. Within LR parser, we have LALR parser, we have SLR parser, or we have CLR, which is canonical LR parser. In this case, we have RDP, recursive descent parser, and LL parser. Now when it comes to LL parser, it is a kind of top-down parser. But what's the definition of LL parser? LL parser comes with two L. The first L means left to right. For example, we are trying to parse a grammar. This one. We will start from the left and then we will go to the right. We will start from the left and we will go to the right. And that's why, since we do the parsing from left to right, we use one L in the LL parser. The second L stands for leftmost derivation. The second L stands for leftmost derivation. What do we mean by leftmost derivation? It basically means in this grammar, suppose this is a grammar, in this we will first derive, we will start deriving from the left hand side, which is, we will start deriving from the leftmost symbol. So A is the leftmost symbol, we will derive this one first, then we will go to the next one. And since we are deriving the left symbol first, it means leftmost derivation. And then we have LL1. What do we mean by 1? 1 basically means we have one look ahead symbol. That's why we use the number 1. What do we mean by one look ahead symbol? So suppose we are trying to do LL1 parsing for this. We will start with S and then we will look at this symbol A. And since this is a terminal, then we will apply different rules to it. So we will first look at the first symbol and then we will make a decision. And that's why we call it one look ahead symbol. If we were looking at both of these symbols, then we will call it two look ahead symbols. So it will be LL2. But we are looking at only one symbol, one look ahead symbol, and that's why we call it 1. So that is LL1. Definition of LL1 parser is, it is a type of parser which goes from left to right. It has leftmost derivation and it has one look ahead symbol. So that is the definition of LL1 parser. Now, how do we know if the given grammar is LL1 or not? So we need to understand the steps to check whether the given grammar is LL1 or not. The first step is to check for, let us type it. The first step is to check for left recursion and left factoring. The second step is to, now first we have to check for left recursion, left factoring. But what do we mean by left recursion and left factoring? So let us understand that first. Left recursion happens in this example. Just check out this grammar. The S is the start symbol, but when we try to derive S, we go to the first S, which is similar to this one. Now when we try to derive this S, we will have to go back to this one, and when we will try to derive this, we will have to go back to this one, and it will just keep on rotating, and that's why it is called as recursion. It will just keep on recursively calling itself. So this is a left recursion, and we cannot do LL parsing on with grammar with left recursion. So we will have to eliminate left recursion first, then we can go ahead. What is left factoring now? Left recursion is when start symbol is equivalent to the first symbol of derivation. But what is left factoring? Left factoring occurs in this example. In this example, you can see that this is an OR symbol. In between the OR symbol, we have two options. This one also starts with small a and this one also starts with small a. And if both of those start with small a, we don't know which one to start with. This is called as left factoring. And if there is left factoring, we cannot check if the grammar is LL1 or not. So first we have to eliminate left factoring and then we can solve the given grammar. So that is the first step, to check for left recursion and left factoring. The second step is to compute first and follow. We know how to calculate first and follow from the last video. So we have to compute first and follow. Third step is to create a parsing table. And we will learn how to create a parsing table. And then the fourth step is to check for overlap. Check for overlap in cells. We will also check this as we solve an example. So let us take an example. Let us consider a grammar. So this is the grammar. E tends to T E dash. E tends to plus T E dash or epsilon. Next one is T tends to capital F, capital T dash. Next one is T dash tends to star F T dash epsilon. The next one is F tends to ID or open bracket E close bracket. This is an epsilon and this is E. So these are separate terms. We don't have to confuse them with each other. So in this case, first step is to check for left recursion and left factoring. Is there a left recursion? Left recursion means E tends to E, T, etc. So anything that starts with the same symbol as start symbol, it means there is left recursion. Is there a left recursion in this? No, because it starts with a different symbol. This one starts with plus, this one starts with F, this one starts with star, this one starts with ID, and even in the OR case, it starts with open bracket. So there is no left recursion. Now let us check for left factoring. Is there left factoring in this? Left factoring is when in between the OR symbol, the starting symbols of these two are same. So plus and epsilon is different, star and epsilon is different, ID and open bracket is different. So there is no left factoring. So left factoring issue is also already solved. So the first step is complete. We checked for left recursion, left factoring, and there is no left recursion, no left factoring. Now let's compute first and follow. How do we compute first and follow? Let us start by computing the first and follow for this. So we will write first and follow. In this case, how do we find the first? We have to find first of E. Now first of E is going to be equal to the first symbol, which is T. But it is a non-terminal symbol. So in case of non-terminal symbol, we have to find first of T. So let us look for T. We can find T here. So let us take it into consideration. Now we have to find first of T in order to find first of E. So what is first of T? First of t is equal to first of f. So again we have to find first of f now. So let us look for f. We can find f here. So let us take it into consideration. Now what is first of f? First of f is equal to, this is an OR symbol. What is at the left of OR symbol? ID. So in curly bracket we will write the ID, and what is on the at the right of I symbol, OR symbol? At the right of OR symbol, the first symbol is open bracket. So open bracket is the second first. So we know that the first of f is ID and open bracket, and we know that first of t is first of f. So we will write the first of f as first of t. So first of t is also ID and open bracket. We know that first of e is first of t, and first of t is ID and open bracket. So first of t will also be ID and open bracket. So we will write this answer here. First of this e is in curly bracket ID and open bracket. This is the first. Now, what is the first of this? First of t, we have already found out that first of t is ID and open bracket. So it's the same for this. Now we will find first of this, f. But we have already found out that the first of f is also ID and open bracket. So it's the same here, ID and open bracket. So these three are done. Let us look for the next grammar. What is the first of e? Now in this case, we can see that in this case the first of, okay, this is not first of e, here it has to be e dash actually. Okay, so what is the first of e dash? First of e dash in open curly bracket, first it's plus, comma, then it's epsilon. So this is the first of e. It's plus and epsilon. So let us write it down. In curly bracket, it's plus and epsilon. Now, let us go to the next grammar, and we have to find the first of t dash. Now, first of t dash is open curly bracket, it's star and epsilon. Star and epsilon is the first of t dash. So let us write it down. It's star and epsilon. Now we have to find out follow of all of this. What is the follow of e? E is a start symbol, and the start symbol has the follow of dollar. So the follow of e will be dollar. But we also have to find out e on the right hand side, because follow is figured out at the right hand side. This is e dash, so we don't have to consider this. This is e, so we can consider this. This is e dash, we don't have to consider this. So when it comes to e, there is close bracket after e, and it is a terminal symbol. So follow of e is also dollar and also a close bracket. It is also a close bracket. Now let us find follow of t. How do we find follow of t? First we need to check, okay, it's a start symbol. So since it's a start symbol, the follow will include a dollar. Now can we find t in any of this? So we can find t right here. We don't have to consider t dash, only t. After t, we have to find the follow of t. So what is the follow of t? After t there is a non-terminal symbol which is e dash. And if there is a non-terminal symbol, then we have to find the first of non-terminal symbol. Now what is first of e dash? That is the non-terminal symbol. We know this is e dash, and the first of e dash is plus and epsilon. Plus and epsilon is the first of e dash. And since e dash is after t, we have to find first of e dash, which is plus and epsilon symbol. So we have to include plus and epsilon symbol in it. But we know that we cannot include an epsilon symbol in the follow. So what we have to do? In this case, if you look at this, we cannot check this, the epsilon symbol. So we have to move from t. You can see there is a t right here and there is a t right here. In both of these cases, if we move to the next symbol, which is e dash, we have to find the first of the next symbol. In this case also we have to find the first of next symbol, which is e dash. Now the first of e dash is plus and epsilon. So we include plus and epsilon, but we cannot include epsilon. So what we do? We have to remove the epsilon in this case, and we have to keep the plus as it is, but we have to replace the epsilon with something else. So what we will do is, after this e dash, we have to move to the start symbol again, because this one contains an epsilon. It contains plus and epsilon. So plus is written as it is, but we cannot write epsilon. So to replace epsilon, we will go to the next symbol. But after e dash, there is no next symbol. So we will have to go to the start. And when we go to the start, it is a start symbol. And start symbol has dollar as its follow. So the follow of first start symbol is dollar, and it is already included. So this part is done. Now let us look at this t. If we look at this t, the next symbol after this t is e dash, and we have to find first of e dash, but we have already written first of e dash as plus and epsilon, but we cannot include an epsilon. So again we will have to go directly to the first. As we went directly to the first and we wrote dollar as the first symbol, we will also go from this e dash to the first e, and we will have to write the follow of e. Now what is the follow of e? The follow of e is dollar and close bracket, and dollar is already there, but there is no close bracket, so we will include close bracket in this, and that is how you have to find the follow. Now let us move on to the next one, which is to find the follow of f. Now in order to find the follow of f, we need to find f in all of this. So there is an f right here and there is an f right here. After this f, there is a non-terminal symbol, which is t dash. So we have to find the first of t dash. So let us write some open curly bracket. Now in this case, we see that f is here, and f is here. For this f, we can write dollar because start symbol has a follow of dollar, so dollar is done. Now for this, so this f is done. Now for this f, we have to go to t dash, and we have to find the first of the next symbol, which is first of t dash. Now what is first of t dash? This is first of t dash. This is t dash, and this is first of t dash, which is star and epsilon. So we have to write the first of t dash, which is star and epsilon. So we write star and epsilon, but we cannot write an epsilon in follow. So we will have to remove this epsilon. But where did this epsilon came from? This epsilon came from the first of t dash, and since we cannot write an epsilon with t dash, we can write the star. We wrote the star, and then we will go back to the first one, from t dash back to the first t, and we will have to write the follow of t. What is the follow of t? We can find the follow of t right here, which is dollar plus and open bracket. So dollar is already there, We need to write plus and we need to write open bracket. Perfect. So this one is solved. This one is also solved. We solved this f. We solved this f. But there is an f here also. So after this f, there is t dash. And we have to find the first of t dash. So what is first of t dash? First of t dash is star and epsilon. And we know that star is already written. But we also have to write the epsilon is not written. So we will write the epsilon. But we know that epsilon cannot be written, so we have to again remove this and we will have to replace this epsilon with another symbol. Now from f we go to t dash, and from t dash we try to find the first of t dash, which was star and epsilon. We write the star as it is, but we cannot write epsilon, so we will have to move from this to this, and we will have to write the follow of t dash. Because when we move to the start, we don't have to write the first of this. We have to write the follow of the start symbol. What is the follow of start symbol? Follow of start symbol is always a dollar. So we will write dollar. So this is also solved now. Now let's try to find the follow of E dash. So first we will write open curly bracket and close curly bracket. And in this, E dash is a start symbol. Start symbol has a follow of dollar. So dollar is written as it is. Now let us find E dash everywhere. So there is an E dash here and there is an E dash here. Only these two places. This one is already resolved by adding dollar symbol. So let us look at this E dash and this E dash. When we look at this E dash, there is no symbol after it. So we will have to go to the start. And when we go to the start, we don't have to find the first of a start symbol. We have to find the follow of a start symbol. Now what is follow of this E? The follow of this E is written right here. Follow of E, which is dollar and close bracket. Dollar is already there. So let us write close bracket, which is not there. So close bracket. Now this one is solved. So this one is resolved. Now this E is remaining. There is no symbol after E dash, there is OR symbol, so we will have to go directly back to the first symbol, which is E dash. Now what is follow of E dash? We know that since we are finding the follow of E dash, and follow of E dash will again be dollar, and dollar is already there. So it is already solved. So this is all there is to E dash. Now let us try to find the follow of T dash. First, T dash is a start symbol. So we will write dollar as the first follow. Now we know that for follow we have to look at the right hand side. In right hand side there is a T dash here and then there is a T dash here. After this T dash there is no symbol, so we will have to move to the start. And when we move to the start, we have to find follow of this T. What is follow of this T? This is the follow of this T. So we have to write this as the follow of this. So a dollar is already there, plus is not there, and open bracket is not there. So open bracket is written as it is. So this one is resolved. Now let us go to this one. To find the follow of T dash, we will go back to the first T dash, and we know that the follow of start symbol is always a dollar. So dollar is already there. So this one is also resolved. So these are all the firsts and these are all the follows. So we have completed the second step also. Now we have to create a parsing table. How do we create a parsing table? In order to create a parsing table, so first we will have to draw it. So let us draw a table. In this table, we have to write all the terminal symbols in row and non-terminal symbols in column. So how many non-terminal symbols are there? We have E, 1, T, 2, F, 3, E dash is 4 and T dash is 5. So there are 5 non-terminal symbols. So we will have 5 different rows. 1, 2, 3, and here is 4 and 5. Now first terminal symbol was E. First terminal symbol is E. Then the next terminal symbol is, we can write E dash. So first terminal symbol was E, second one is E dash, third one is T, fourth one is T dash, and fifth one is F. So these are all the terminal symbols. We have to write all the terminal symbols in this column in different rows. Now we have to write non-terminal symbols in the first row. So how many non-terminal symbols are there? We have these non-terminal symbols, which is, we have ID 1, open bracket 2, dollar, no, dollar is okay, dollar is also there, so 3, close bracket is 4, plus is 5, and star is the sixth non-terminal symbol. It means we have 6 non-terminal symbols, so we will need 6 columns. First column, second column, third column, fourth column, fifth and sixth. Now we have plus, we have plus, we have star, this is plus, this is star, then we have open bracket, close bracket, and we have dollar, and okay, ID is remaining, so dollar has to be last and ID is there, ID. These are all the non-terminal symbols, ID, open bracket, dollar, close bracket, plus, star. Now how do we fill this table? In order to fill this table, we have to look at the first of each one of them. What is the first? Look at the first of E. The first of E is ID and open bracket. So ID and open bracket. So in this ID, we have to first name this something. So we will call this equation as 1. We will call this equation as 1. And it has ID and open bracket. So we will write 1 in ID and we will write 1 in open bracket like this. Now let us look at E dash. E dash. We will call E dash as the second equation. We can give any number to any equation. So we will give second number to E dash. Now the first of E dash is plus and epsilon. So since there is plus, so we will write 2 because it's the second equation in the plus. Now what about epsilon? If there is an epsilon, what do we do in this case? In this case, we can see this one. So in this case, we have to look at the follow of it. So when there is an epsilon, only in that case you have to go to the follow. Else you only have to look at the first. So now you will go to the follow. In follow you have dollar and close bracket. So you have dollar, so write 2 in dollar, and you have close bracket, so write 2 in close bracket. This was the close bracket and dollar. Now third one is T. So let us give 3 number to T. This one. What is the first? ID and open bracket. So 3 will have open bracket and ID. This is the correct answer. Now let us go to the next one, which is fourth, with this T dash. So we will call this one T dash. Now look at the first, star and epsilon. So we will write 4 at the star. But what about epsilon? In case of epsilon, you have to go to the follow. In follow, we have dollar, plus and close bracket. So we have to write 4 at dollar. Okay, so this is dollar, then there is plus and then there is close bracket. So then there is plus and then there is close bracket. Okay, now last one is f. We will call this 5 number equation. So let's call it 5. So in case of 5, what is the first? ID and close bracket. So ID will have 5 and close bracket. Is this close bracket? Yes, it's a close bracket. So in this, okay, no, it's not a close bracket, it's an open bracket. So for open bracket, we will use 5 like this. This is how the equation looks like. Now in this table, you have to check that we can see that all null productions, which is epsilon, are put under follow set, and else everything is written in the first set. Now if there is a condition where both of the numbers, for example, there is a 3 here and there is also a 4 here, in that case we can say it is not an LL1 grammar. But in this case, each cell has only one number. Each cell has only one number. So when each cell has only one number and there is no cell with more than one number, so there is no cell with more than one number, we can say that the given grammar is LL1. So the last, we have created a parsing table and we have checked for overlaps. So there is no overlap, which means that there is only one number in each cell. It's not like there is 4 and 5 in one cell. So even if there is one cell where there is more than one number, we can say it is not LL1 grammar. But there is no cell with more than one number and therefore it is an LL1 grammar. So let us take one more example where the given grammar is not an LL1 grammar, so we can understand it better. So let us take another example. So what is the answer of this? The given grammar is LL1 grammar. Because the question is, we have to check whether the given grammar is LL1 or not. So given grammar was LL1. Now, this is the next question. S tends to A, S, B, S or B, S, A, S or epsilon. So this is a given question. Now in this question, we have to check whether the given grammar is LL1 or not. So for that, we have to find the first and follow of this. So how do we find the first and follow? So let us keep it right here and let us try to find the first and follow. What is the first step? The first step is to, the first step is actually to check for left recursion and left factoring. Is there left recursion? There is no left recursion, because if this starts with capital S, then there is left recursion. If this starts with capital S, then there is left recursion. If this starts with capital S, then there is left recursion. But there is no left recursion. So no left recursion. Is there left factoring? This A is different from this B, different from this epsilon. So they are starting with different symbols. If this was also starting with A symbol, then we will say there is left factoring. But there is no left factoring. So the first thing is checked. Now second thing is to compute first and follow. Now let's compute first and follow. The first of S is equal to, in open curly bracket, A, B and epsilon. What is follow of S now? Follow of S is equal to open curly bracket. Now we have to only check for right hand side to create the follow. And if the given symbol is also the start symbol, which in this case, yes, S is also the start symbol, So we will also include dollar as the follow. Now we have to find S. So here we can find an S, here we can find an S, here we can find an S, here we can find an S. After S there is B, so we can write B. So this S is resolved. Now look at this S. After this S there is no other option. So we will go back to the start symbol. When we go back to the start symbol, we have to find first of the start symbol. Sorry, the follow of the start symbol. Follow of the start symbol is always a dollar and it is already written. So therefore this is also resolved. Now these two are left. If we try to find the follow of this S, we have to go to the next symbol, which is small a. So small a is also follow. So this is also resolved. Now let us go for this S. After this S there is no other symbol, so we will go back to the start symbol. When we go back to the start symbol, we have to find follow of the start symbol, which is a dollar and it's already written. So therefore B, small a and dollar, these three are the follow of S. So we have found the first and we have found the follow. So the second step is also completed, which is to compute first and follow. Now third step is to create a parsing table. Let us create a parsing table now. How do we create a parsing table? We have to write all the terminal symbols here. We have to write all the terminal symbols here and non-terminal here. So how many non-terminal symbols do we have? We only have S as a non-terminal symbol. So there we only need one row. How many non-terminal symbols are there? S. So only S will be here. Now how many terminal symbols do we have? We have small a, we have small b, we have dollar, and that's all. So we need small a, small b and dollar, only 3 columns. Now small a, small b and dollar. Now we have to write a number to this. So this is the first one, so we will write 1, and there is no other grammar, only one grammar. So 1. Now what is the first of S? The first of S is A, B and epsilon. So since the first of S is A, we will write 1. Since the first of S is also B, we will write 1. Since the first of S is also epsilon, when there is an epsilon, you have to check the follow. So what is the follow? $BA. Okay, in this case, what you have to do is, if you look at the follow, you can see that there is a dollar. So in this case you have to write 1, but there is also B and there is also A in the follow. So we have to write 1 again and 1 again. So in this case what we can see is the first and follow are overlapping. So in the previous answer we can see that there was no overlap between first and follow. There is a different symbol in first, there is a different symbol in follow. There is a different symbol in first, there is a different symbol in follow. But in this case, the first has AB and even the follow has AB. So in this case, we have to overlap this twice. We have to write AB twice. And in this case, it is not LL1. Why? Because in the last step we created the parsing table, but when we checked for overlap, there is an overlap. So it is we checked for overlap and there is an overlap, so it is not an LL1. So this is how you figure out